The next speaker is Professor Mark Howden from the Australian National University. He's Director of the Institute for Climate, Energy and Disaster Solutions. And he's also a Vice Chair of the Intergovernmental Panel on Climate Change, the Working Group 2 section of that. And Mark is going to talk now not about the IPCC and not really about the Institute for Climate, Energy and Disaster Studies, but he's going to talk about the changing climate heartbeat of Australia, not just on a year-to-year timescale or even on a 100-year timescale over multiple millennia. Mark, over to you.
Thanks, David, for that introduction, and apologies for not being here this morning, but I was at a meeting with Purple House, who are an inspirational First Nations health deliverer in this region. So what I'm going to be covering is essentially what I think of as the heartbeat of Australia. That's the greening and the browning and the greening and the browning that we see across our wide nation. And as David mentioned, I'll be dealing with this on a range of different timescales. So it's the down button that takes us forward, I gather. That's the trick there. So starting off with the hundreds of millions of years, Australia used to be part of a supercontinent called Pangaea, and around about 200 and something million years ago, Pangaea split up into Laurasia and Gondwana, and then around 180 million years ago, Gondwana started to split up into Africa and Australia and various other components. And when we start looking at this very, very long timescale, we still see the faintest whisper of these changes happening today. So Australia still is moving. So the eastern part of Australia is moving north about 6 centimetres a year, the western part about 4 centimetres a year. It's slower because the Himalayan plate is blocking that movement. So we're seeing a gradual twisting of Australia as it migrates north. There's a little element of climate change that happens every year as a result. But within this picture of hundreds of millions of years, Australia at times has been significantly affected by ice. And so we've had significant glaciers in Australia and similar factors. But at the same time, it's also sometimes been tropical rainforest. So this long scale, a geological scale, has seen this massive greening and browning of Australia in that sort of 100 million year type time frame. If we go down about 1,000-fold, we get into the glaciations, what people call the ice ages. This is from the Epica core, the longest ice core so far mined and explored. And this shows the combination of carbon dioxide and temperature variation across those ice ages. And we can see that carbon dioxide levels and temperature very closely linked. They feed into each other, and that's why we get the sort of big changes in climate that we observe due to relatively modest changes in astronomical features, the distance of the Earth from the sun. And importantly, those ice ages, or what we call the glacials, the cold parts of our history, and the interglacials themselves caused major browning and greening of Australia on the sort of 100,000 year timeframes. So when we go into those glaciations, the dips in that record, typically Australia was much colder than we've experienced it historically. It was also very much drier and windier than we've experienced historically. The monsoon, which brings our summer rainfalls in this part of the world, was much, much weaker during those glaciations. We saw large-scale vegetation changes happening, and some of them weren't recoverable. So, for example, around 280,000 years ago, we saw a big shift in that glaciation from essentially rainforest vegetation into the dry sclerophyll vegetation, which characterises Australia. And as a result, we saw major changes in our fauna. Big slabs of our megafauna disappeared in that time frame. So we see that sort of beating heart operating on that 100,000 year time frame. And in that last glaciation that we experienced, estimates are that the population of Australian humans decreased by about 60% during that time frame because it was such a tough environment to live in. And the megafauna disappeared around in that time too, about 40,000 years ago, particularly as a function of those climate changes that occurred there. And we see the remnants of some of those events happening right now, including through, say, the palms in Palm Valley. So the refugia that animals and humans and plants required to survive those tough times are important now, and they may actually become even more important in the future. The beating heart of Australia at that 100,000 years still has something to tell us. If we zoom into the sort of decadal type timescales, we see the interdecadal Pacific Oscillation, sometimes called the Pacific Decadal Oscillation, and we can see how this goes up and down, roughly on a 10-year sort of period. And importantly, that brings the long dries and the short dries, the long warm periods and the short warm periods that we experience in that sort of decadal timeframes, influencing things like our river flows in the Murray and other things. And if we then start to look at the human influence through climate change, we see this as yet another scale of variation driving change, as well as those million-year, 100,000-year, 10-year sort of timescales. And so this is a graph of the carbon dioxide releases that we have each year from industrial and electricity sectors. And you can see that that just keeps going up and up. Slight decreases during the global financial crisis and during COVID when big shutdowns happened. But after COVID last year, we bounced back to record levels. And that's really important because carbon dioxide is the single biggest driver of climate change, which is actually causing faster and faster change across our different systems. So for example, sea level rise is accelerating right now. Last year was the record sea level rise recorded, around 4.5 millimeters on average across the globe. The average for last century was around 1.8 millimeters. So we're seeing this acceleration of factors happening because of this emission of carbon dioxide. And at that geological timescale that I talked about before, this is really big. This year we peaked at 421 parts per million. That's 50% higher than the pre-industrial levels of carbon dioxide. So we're mucking around with our systems really, really badly. And that level that we're experiencing now is higher than it has been for at least 2 million years. And if we look at other greenhouse gases like methane, nitrous oxide, we see similar factors, record emissions, record levels in the atmosphere. In the case of methane, it's triple the pre-industrial levels. So big, big changes that we're driving. Now, how does that influence the beating heart of Australia? Well, really significantly. So as you'd know, one of the critical heartbeats of Australia is what happens to the El Nino, La Nina cycle. This year, last year, the year before, essentially in La Ninas, bringing wetter conditions than average across parts of Australia. And we're already seeing, according to this analysis and the recent IPCC report, significant influences of climate change on El Nino. So not necessarily changes in the frequency, but changes in the intensity, the strength of El Nino and La Nina events. So in the La Ninas, we're getting more rainfall, and in the El Ninos, more drought than we used to get. This is a graph from Scott Power from the Bureau of Meteorology, and that shows that the assessment is that climate change has already influenced that intensity of El Ninos, the disruption, the difference between the positive and negative cycles. And if we go on a high emission scenario, that disruption is going to increase dramatically. It's less, but still somewhat more increasing if we go on a low emissions trajectory. And other big drivers of climate variability in Australia, such as the Indian Ocean dipole, what happens in our Indian Ocean, are also influenced by climate change. So particularly the drought elements of Indian Ocean temperatures are also already increasing through climate change and increasing potentially more. So that, again, that heartbeat, the greening and browning of Australia, driven by El Nino and other factors, seems to be increasing. So this is a couple of graphs that show that sort of heartbeat. So this is the pasture growth assessment as modeled by the Queensland colleagues for a wet year on the top left and a dry year on the bottom right. These are relatively recent years, and you can see that heartbeat as it expands and contracts. The greenery expands and contracts aligned with the climate variations we experience. And it's not just that we're seeing that interannual variability, that sort of timescale of heartbeat, but we're also seeing changes in seasonality, the sort of 3-monthly type climate signals. So this is a couple of graphs from David Stevens in Western Australia. And what he did, he looked at essentially the seasonality of rainfall across Australia. The top left is how it was historically. The bottom right is how it is now. And we can see that essentially that summer-driven rainfall component has crept downwards across Australia. It's the tropicalization of our climate. So we're getting more of the summer-dominated and less of the winter-dominated rainfall influences across Australia. And essentially the arid zone is pushing outwards down into the southwest and southeast. So again, we can start to see that heartbeat operating at that seasonal timescale and how it's changing. And so the thing that I just want to sort of leave it with you is that when we talk about climate, and we need to recognize that climate varies and that heartbeat of Australia varies over many, many different timescales. And it's the sum of all of those timescales that contributes to what we're experiencing this month and this year. So it's that geological, and that's that decadal, and it's the interannual, and it's the seasonal, all added up together. So when people talk about climate change, we need to think comprehensively. We need to think about those 100,000-year timescales as well as what happens tomorrow.